So this is Where's Bo Peep, which is a storytelling game for children that I created as part of a Tangible User Interfaces course, along with Margaret Lagan and Wendy Xu. And the idea of the game is to allow children to explore this virtual world using this sheep puppet to look for Bo Peep, who's gone missing again. So inside of this puppet is a mouse, a computer mouse. So the program runs on a regular computer. But what's interesting about this mouse is that it has touch input on top of it, so it can sense where your finger is located. So when you put your fingers inside of the puppet, you can control the sheep's head, and we can read that information as gestures and use that to inform our program. As the sheep, you might think that little Bo Peep is hiding, say, inside this cave. So you move as the sheep over to this cave and poke your head inside. And when you do, the game tells you, oh no, Bo Peep isn't in the cave. You better keep looking and find out where she actually is. So maybe you think that Bo Peep is hiding at home. Maybe she's been at home the whole time. So you move up to the door, and being a sheep, you can't knock on the door normally, so you knock on the door with your head. And the game plays some audio of the door opening and Bo Peep's mom coming and saying, sorry, Bo Peep isn't home right now. So, okay, maybe I should go check over here in the garden. So you move over to the garden and you look around in the garden, and once you're over there, you find Bo Peep. And then you've successfully found her. Our idea on this project was that we wanted to create something that didn't necessarily use a traditional computer interface. We didn't want children to be sitting in front of a screen. So instead we wanted them to be able to play with this sheep puppet, to be able to sit around the table with their friends and talk about the program the story that they were creating. And that way to take them outside of the screen and give them a more interactive and storytelling experience.
So here we have a demo program where the user can use the 3D glasses to observe how 3D models pop up, and they can use the stylus to move around different parts of the device. This setting would be used in like a medical setting. So here all the objects are interactive, and our goal for this device is to basically test how people interact in a 3D modeling environment, as well as whether there's any thresholds in terms of their capabilities for interaction. So if we give them a puzzle piece in real life compared to a puzzle piece on the screen, would they be faster at solving the real life puzzle or on the screen? And this is a level for engineers. As you can see, the subject is taking apart a hand. So engineers, when they design a hand, they can interact with all the components of the hand and test whether each component is working to its order.
So this is the Beast. It is the largest seated height multi-touch interactive surface. It's based on diffuse illumination technology, similar to the Microsoft Pixel Sense line. So it makes use of 3 cameras, a diffuse illumination setup, and 3 projectors to create the image that you see here. The cameras gather the reflected light from the IR lights, and then the computer processes them into what are called touch events. And it tracks the blobs, and from there you can get this multi-touch interactive experience. Our eventual hope is to use this hardware to support groups and group planning and sort of tactical applications where you can plan spaces and plan. In our particular case, we're talking a lot about scientific inquiries and supporting scientific education in undergrads.
What I'm showing here today is something we're doing in a course that I'm teaching this semester. It's called Web Mashups. And in the first weeks of the course, my students are learning to build mobile apps for Android phones. And we have here an Android phone. So we start with an empty screen, then we take a picture of someone. And once the picture is taken, we can go and pick colors, for example, orange, and let's change the line width 12, and then start doing stuff. We can pick another color and do dots, and change to another color, change the line width to something smaller, and and we can then also decide to send it. It gives us a message that it's ready, and we go back, and if we refresh it, this picture now it's right here, and I can open it so that we can print it.
This is an application created for the Wellesley College horticulture class that helps them collect data and then come back to create data-driven hypotheses from that data. The idea is students can go into the field with these iPod touches, collect and find a plant. They can then collect data on that plant using this device, collecting data about their health, phenology, and getting photos. That data is then saved into the cloud and then transferred to this system on the Microsoft Surface. So what you can do now is see what data was collected on each of these plants. So you can see things such as the photos that were taken for a plant. You can also get graphs that are generated from this data. And the idea is by having this data readily accessible for these students, it really lets them create better hypotheses by having the data presented nicely and by letting the students collaborate on these hypotheses. So this here is a graph of the health. You can pick what kind of things you want to look at. So say you want to focus on the leaves and the stem. You can get rid of this and kind of see the progress over time that this plant has gone through. And this is all data that was collected last spring in the horticulture class. People seem to like it. They did come up with some very interesting hypotheses that they may not otherwise have been able to come up with had they been using traditional methods of data collection and analyzation.
Yeah, so this level is more for architects. So you see that red button there? If you slide it up and down, yep, you see the different levels of the houses. And architects can translate blueprints into fully 3D models to test them out.
Belong to somebody that we know?
Yeah, we should probably move it.
Yeah, I'm afraid.